السلام عليكم ورحمة الله وبركاته. معكم معتز عباس. أولا أشكر ArchiNet على تنظيم المحاضرة، دعم الطلاب دائما في المحاضرات عندهم، وأشكر دعم الملك سعود أيضا على استضافتي المحاضرة. طبعا راح أتكلم نقول ببدأ بقصتي كيف دخلت الهندسة المعمارية بشكل عام، بعدين بعض المشاريع سويتها في البكالوريوس والماجستير بعد الماجستير. طبعا أنا عشت مع عائلة تحب التصميم من البداية، فمنذ الصغر دائما مع الوالد في البناء، والوالدة الله يحفظها كانت تحب شيء اسمه ايكيا، دائما كل يوم نروح ايكيا. وكان الكتب اللي لو سألوني الكتب اللي أقرأها ممكن أقول هذا أكثر الكتب اللي قرأتها اللي حقت ايكيا، وتجرب التصاميم ولا دخل الأشياء على بعض وتمش طاولة مع كرسي، ويعني كنت أسوي فيها. طبعا الوالدة بعد نفس الشيء عندها لمسة في التصميم، رغم أنها ما أخذت مجال التصميم، ما درست مجال التصميم، بس في لمسة architecture من البداية يعني من الصغر. كانت تحب يعني حتى الأشياء في توصل الأشياء مع الورد مع الإضاءة وين أماكنها وين. على قولتهم I grew up in I just remember, I'm sorry, there's someone speaking English, so if that's fine for you I will speak English. ما عندك مشكلة. So when I was in high school I got invited by مؤسسة الملك عبد العزيز والرجال الموهبة والإبداع لحضور دورة to go for a workshop in King Fahd University. So when I was there I got to experiment some robots and to design them and to do some works with them. And I also had to meet the architecture students in King Fahd and know about the architecture. Then I went to Los Angeles. I started looking for the best universities in architecture, so I found this university, Wودبيري University, which was one of the top 10 universities in architecture in the US. The university always encouraged students to use softwares, and the main software that they were using is Rhino code. And Rhino started with, I would say, with designing furniture, designing accessories. It wasn't meant to be in architecture field, but there was some firms in architecture that they related it from just accessory to architecture. And the main one was Zaha Hadid. So she used her imaginations and she pushed her ideas about curves and architecture with the software. And the main one was Rhino. So I started, that was my first project. I started in using Rhino. And it was an athletic center. So it was very, very easy from hand drawing, because the first year was hand drawing. And the second year I started using manipulations and lines in Rhino, so it was very fast. And then I came back, when I was in modeling, I came back to the idea of IKEA and let's say assemble things together. So I wanted to assemble the model with the contouring and the same idea as I did in IKEA. The model was, I would say, start with the first layer, and then you put it on top of each other into the top view of the site. So the site was in a land, let's say land hill. So it started from the top, and then you go down all the way here, and it has ADA accessible. So we had to design it and manipulate the site. So I created 45 degrees grid, and then I started applying the geometry. So the geometry followed the grid, the design. From that studio, we took materiality studio. So we had to experiment with materials. And the teacher for that studio, he was a Japanese architect. His name is Yasushi Ashida. And he was one of the architects who worked on the Broad Museum. I'm not sure if you guys heard about it in Los Angeles. So he was one of the architects who worked on the skin system. And he used also Rhino and Grasshopper to create the geometry and to manipulate them more faster in Grasshopper. So if you don't know about Grasshopper, Grasshopper is a plugin into Rhino. So you can download Rhino and you can have Grasshopper into it. So that was one of the buildings, some of the pictures, and they had, I think, about 50 molds, and then they just used the mold to cast GFRC material, which is the white cement with the fiberglass. So they wrote the codes and definitions in Grasshopper, where they try to, I would say, the skin system, the way how it works, it avoids earthquakes. By, let's say, if there's an earthquake, so the skin system of the building moves, while the building in the middle doesn't move. So the skin system would like just jiggle while there's an earthquake. So they did some tests and definitions from Grasshopper, and that was one of the tests they did to for the, let's say, for the mass production for that building. So from there we started playing with materials with no software. We played with fabric, we played with paper and origami shapes to create some shapes. So we chose, my team and I, the team were created by 3 students. It was me, Saif and Fahad. They were my friends and also colleagues in Wودبيري University. So we chose the free-form origami and we started folding the papers to create the forms. So we, as you see, we use some clips just to show. And the idea of the origami, it's a fold in and out. So you have some folds until you get the geometry and the 3D. From there, after we did some tests, some of them were successful and some of them were not, we started having system in the work where we had the base geometry, as you see on the right, and then we have the 4 or 5 sheets. We put them together and then we start folding them to create the dome, because we wanted to create the dome. And that was the final test of the dome. So this model is created by paper, and then we apply to the paper the GFRC material, or sometimes plaster. So we were testing the materials. So we just started playing with the material and see the results. And that was the result. So this, instead of a paper, it became a GFRC material that it's very rigid and you even can step into it. We decided to go a further step. We wanted to have something that all the university talks about it. We wanted to just build something big in the university. So we had the idea of building this. So the teacher came to us, Yasushi, and there was 2 weeks to finish the project. And he told us, you guys are not going to make it. There is no time, and you are only 3. So let's say we stick to our mind with a little changes. So we try to do it from a structure and something dangerous to something in the ground, at least if it didn't work and collapse, at least it's close from the ground. So there was supposed to be a video. I'm going to try to turn it on. So the idea is we have a half dome, and we cut it to have to allow the entrance for the geometry, and then we try to create the geometry in Grasshopper, which is a triangulated geometry, and then from there we use a software that was developed by Yasuji's friend. He was an architect, and he developed a software called Freeform Origami. So what this software does is created your 3D model into a sheet of paper that you can fold it and you can create the geometries. So with just one press button, you can change the model from, you can change it from 3D into a sheet that's ready to fabricate and make it ready. So we did the drawing in Rhino, and then we prepared it for digital fabrication. And as you know, the laser cutting is very small. It has very small size. So we had to, let's say, divide the sheet into 62 sheets, and each, let's say, star, it has a number next to it. We put them all together, and then we started arranging them, and then we had to put all the sheets together. So we used tapes just to put them together to create the shape. And from there, we created the geometry. And it has to, we used a plastic sheet just to create it. And then we had to build a base for it, since we are using a GFRC material. So the GFRC material is very rigid, and we are going to put it in a piece of paper. So it will not handle the GFRC. So what we did, we created this base, and then we transferred the sheets after we put them together into this base. So we put everything, and as you see, the idea started with 3 people, and then all of a sudden, the whole city started to help us and to create they got very excited with the project. So as you see, the numbers, people would go there to hang out and talk to us, and then just build with us. And then we had to flip it, because it was upside down, and we had to flip it. So we were thinking of using a crane, because it was very heavy piece to put. So we had a lot of ideas of flipping it, and then we came up with just connecting all the students in the university at that time and asking them for help, and they were happy to help. So as you see, we started using the manpower instead of a machine to flip it. And we were we were not sure that this would work until the last minute when we flipped it. So the whole school were excited and participated in that project. And we had to clean up everything and make it ready. And that was the final shape, and it was, the thickness of it was less than 10 centimeters, and which is comparing to the architectural scale is very, it's very fragile, but we just made it because of the freeform origami where the shapes get stronger. And we did some tests on it just to see if it's working. So, and that was the 3 of us that made it by the end of the class, and the school decided to keep it for their in their courtyard. From there, I wanted to do something in my thesis that has to do with clay. So I tried experimenting with clay. So I represented my thesis instead of drawing. I represented with clay, and I represented the water with the ink and clay. So I was doing some experiments. So while I was doing those experiments, I came up with the idea, why don't we create those geometries but with software? But that was in 2015, and I couldn't, because when my professor asked me to show whatever I did here, and in a drawing, it was very hard for me to make the shape. So I had to go trace it and do some work on it. Yeah, so those are some of the experiments I did with them. And then I cut a section through it, and then I took the geometry. I also did projections to get the lines. And those were some of the tests. So the ink would act very, let's say, organic when it touched the clay. And I actually got very excited and interested to reproduce this with, let's say, with the software. From there, after I graduated from Wودبيري University, I was looking for schools. So I applied to grad school, and I got accepted into Columbia and into SIRE. and I visited both campuses just to see how they do, because they had final reviews, so I had to visit both of them. When I visited SIAC, I was very impressed actually. Before I'm going to explain about the models, their work, I'm going to explain one of the teachers that was teaching at SIAC, which is Gary. And if you don't know Gary, he's the designer of this building. There's actually a funny story with Gary. So Gary used CATIA software to design his building, because all the engineers, he had to go to a lot of engineers and convince them with the idea, and all of them refused. They told him this cannot be done. So he had to go and invent, let's say not inventing, but also reinventing a software that's used for the airplanes, to design airplanes, which is CATIA. And he had to change it to work with architecture. So he brought, let's say, I think 10 engineers, and he taught them for a year how to use the software CATIA. And after 1 year, they came back to him and they told him, yes, that can be done with this software. So it was very successful for him and changing point in his life. So he started building and using CATIA for that. As you see, the system integration, and it was very hard to build something like that. This is another building also, University Foundation he made, and at the same time, the same thing, he used CATIA to construct his buildings. So from there, what I learned from there is you need to go and to look for software that are not usual in architecture. Just go and find something else. You might find something interesting to do it and build it. So he had the passion to build it, and he did. So he had a lot of very nice buildings, and one of them is Easy Bank building. So he did the interior and some crazy shapes. And if you look him up, Gary, you're going to see a lot of buildings that are curves. Also, the other facility, the other teacher or professor at SIAC was Tom Main, and Tom Main also was the founder, one of the founder people at SIAC. Also, at the same time, he uses Rhino and Grasshopper to create very crazy geometry and shapes. So that there are some buildings. This is Emerson College in Hollywood. So let's say people, it's a college, so the students would live in the side, and the school will be in the middle. And you can see there is like just seating and stairs. And while you sit in the stair, you can see the Hollywood sign from here. So at the same time, they use the grasshoppers to manipulate the SAT system. So coming back to SIAC, I was very impressed by the model technique and let's say the 3D printing and visualization. And it's not only a model, but also you could see it in their teachers, that they have real buildings. Because some of the students or some of the people, they were arguing that those models were not going to be built, it's just an idea, but then when you come and check the portfolio of their teachers, you're going to see something very interesting and very impressive. So those were some of the models for the trade show, where they used 3D printing, and so everyone is trying to invent a new technique in their designs to show that they have a better quality of designing and also executing. So they would use different materials, they would use the robot arms just to fabricate their work. From there, let's say the challenge was very difficult for me to compete with them. Especially the school, SIAC, most of the students there were from China. They were Chinese people. So as you know, Chinese people are very hardworking. So you had to compete with them and to have the level of complexity they have. So I started using a lot of software and try to mix things together just to impress them and to level up to the level they have. And the surprising thing is, whenever I do something, the next day they would do the same thing as me, and the other day they would do something better. So it was a very competing, let's say, a place where you have to learn a lot and you have to produce a lot just to be better at that school. And the teachers, they push for the idea of creating something new that's unusual in that school. So we had to use the robot arm. So the first studio for us, we had to, let's say, 3D capture the model of unity rehabilitation in France, and we had to reproduce them again. So the idea we came up with it is we took the model over here, and we did the motion movement, and we created geometry from the motion movement from there. We also did use the clay again, but with the robot. And at this time, we used the clay in a different method. So what we did, we had a setup. We put the clay in front of the robot arm, and we had to wear the VR. So we would just carve into the VR, and the robot would do the same thing. So that could open up a lot of possibilities for us for fabrication. يعني دائما نقول العين بصيرة واليد قصيرة، فالمثل هذا الظاهر انه راح مع الشيء هذا. You could just put your robot arm in a very high level in the building, and you could just do it in the VR, and it can do the work for you. So that opens up a lot of possibilities in architecture. One of the projects I worked on was in the school was a Death Star 2. So we had to reproduce Death Star 2, but with let's say with a different concept. So the concept we came up with, we were a team of 2 students, is when you zoom into Death Star 2, you can see it's made of buildings. And as you know, Death Star 2 is just a concept, so the models they did in the movies, they were not very accurate, just for the movie. So what we did, we zoomed in and we took some of the buildings, and we started designing some of those elements. And then we had to mash them together to create the geometry. So we came up with this concept. It's a sphere, and then it gives you the feeling that it was destroyed. So we had to do it again, and then we had to assemble. The class focuses a lot on the assembly and how you can assemble things together with 3D printing. So if you see this object, it was made of, I think, 8 pieces that we had to put together and how we had to interlock them. So it was a very interesting project that you have to experiment with materiality, and you could see, because since we had the pin-up, and you know the architecture students had the pin-up, it's a very mess. So we had to produce 2 models. One of them was powder model, and the other one was 3D printed, and we had to use some help. That was in the midterm, so we had to use some help from other students where they had different filaments just to show the idea. And the final result was this. So we wanted to have the really dark side of the Death Star, and from inside there is a city. So we called it a city within a city. From there, my last studio was with Hernan Diaz, and he was the head of SIREC. And Hernan, he's always known about pushing technology in architecture, and he has the idea that everyone can have access to technology. But who can make difference in technology and architecture? So that was his vision, is to create something that no one has done it before in the technology. So he started doing some crazy geometries and some buildings. And most of them were concepts, but he had some exhibitions. Since he was the head of SIREC, so he's focusing a lot on the academic part and pushing for the research based more than buildings. So he had an exhibition in Los Angeles where he created those geometries. His studio was very weird because we had to, our site was in Beijing, in China. And we had to come up with the idea that there's this machine that cleans, let's say, the dirt, cleans the air in the sky. So we had to do a lot of visual effects. So one of the first visual things I did was this object where I had to use some movie sets, like the same what movies do, where I had to mix the videos with the 3D models. And that's the other one where people had a very bad weather, and this object would just fall next to them, stops to the right, means the weather, and then just keeps on going and rolling in the seas. The final review, there was even Peter Cook, if you know him, the architect, he was also there at the review. And we had to produce a 360 image, a 360 video, where the whole thing is going to be immersive, where all the objects, they move around. So that was one of the objects I made here.
What software did you use to do this?
So I tried different softwares. Mainly it was Cinema 4D to produce the effects, but the geometry was made in Rhino. So I made the Rhino and then I put it in Cinema 4D. There was a lot of, let's say, intersecting between softwares, because I had to try to create something new that's never there, and try to push even not only the, let's say, the visual, but also even the fabrication, and to make it ready for 3D printing, for laser cutting. And this is another object I made. And honestly, this field opens up another field for me, which people started calling me digital artist instead of architect. So I liked that idea, and it started even go further from there. So and another idea we did is to mix fashion with design. So we had to go to a place where you stand in the middle and they take 360 pictures of you and transfer your images into a 3D model, and you can start manipulating it. So that was me. They chose me because I was the tallest guy in the stadium, even though there was like taller people. So we created this. Let's say we took some balloons, we put them together, and I wore them, and then we just went to that room and take 360 images. So it created all those point clouds, and then connected them together to create the 3D image. And that was the final result, where we had model and put them together and just manipulate them to create new geometries and, let's say, new fashion design. This is another way. And you could see the legs, some of them they were cut. We had to do a lot of testing. After that, I started experimenting from materials. I went away from let's say, architecture to architectural visualization more. And this was not in school. It was just on the side while I do my study. Because since I learned a lot of softwares, it was very easy to produce the work for studio. So I would produce the work in the studio for like 2 or 3 minutes, and the rest of the time I would just spend it just experimenting with new software, posting it on Instagram. A lot of people had their reactions, or I get more experiments. So this one was fractal art, 3D fractal art. And if you don't know about this software is based on algorithms. It just reads your algorithms and change them to 3D. So whenever you change number, let's say the equations, they change for you. So I had to change some numbers, and then I had to do fly, and we can go inside the visualization. And what's nice about this software, the 3D fractal art, is it never finishes. You can go and go and go for, like, let's say, it's endless things. So that's one of them, and the other one was that, which is also in the scene where it's created optical illusion where you think you're going to finish somewhere, and it will never finish. And what I liked about that software is also had to do with architecture, visualization, and these things. So I had to think about it, if we can create something. So that was, I took some video for the software just to show you how it works. So there's equations in the right, and there's the image. So you just start changing some numbers and some values, and each value just represents a new thing for you. And you could even just, let's say, upload images to the software instead of just using some preset images. It's a very powerful tool. And there is actually another architect. He used this idea of fractal art, but what he did, each image, they scanned it at his office, and they started building. I actually did not include him, I just remembered now. His name is Mark H. Foster. So he did some buildings of that. I will show you guys. I came back again to Broad Museum since my school was close to it. And then I started thinking, why don't I use whatever I did in Hernan's class to this building? So I did generative design, where I had to do physical simulations and act that those geometry would go into the building and just go even in the streets. So this is an image based. It's just an image, and then I had to do some planes, as you see. Created this plane, plane A, plane B, and then the surface in the bottom.
Cinema 4D also?
Yeah, so that's Cinema 4D, and I also used different softwares for the rendering because they had live rendering. So I did it on the side where I had to see my work like at the same moment. So this geometry is based on algorithms at the same time. So where you have to change numbers and then you get some new geometries. Then I went a little bit further from architecture and I started playing with geometry, but with let's say with shapes. So I created this geometry, and what it does is you have the person, and it's a 3D person. Then you connect the point from that person, and instead of connecting the arm to the other arm to the neck, it started connecting this hand with the chest. So it started just putting things, messing things up. And I did this with you, where let's say you can change and you can move it. So the idea is.
What do you call this art?
Well, what do you define art? What do you think what's art?
Art is your own expression of creation. You have created a very unique expression that you wanted to present. So what do you call it?
Well, for myself, I honestly did not call it art. Or I did not like the saying of artist. Because I'm just enthusiastic about software and architecture and how I can bring this together. But this opens up a lot of opportunities for me to test something else. So the idea is, as you see, there is this geometry, and then you have the person, and you try to connect the points. As you see, the geometry started created. Let's say real geometry, and then the setup with the camera, and then just connect them together. And at the same time, we have the, let's say, the image on the right, so you can check them out. In this video also I did some setup. I actually did not include the final result. Also, I started playing with graffiti, so I changed the graffiti, since we can play with the graffiti also in the software. So I tried to play with the graffiti where the airbag would take the car out. From there, I came back to architecture, and I wanted to create a new geometry that's created by visual effects. And as you see, this image reminds me again for my bachelor when I was trying to figure out the shape when the clay got into the ink. So I finally got something there where I can start playing with it. Not only that, I started also playing with the geometry, as you see in the middle, where I used Rhino and Grasshopper to create a structure, and then I asked this, let's say, creature to come over the spider. So I call it golden insect. So I had this spider, 3D spider, and then I created the, let's say, the setup, as you see in the triangle, green triangle. And then after I put all the numbers, the algorithms, I asked it to do the physical simulations. So after I changed all the parameters, making sure everything is working, and using the branching technique, I just pressed the button, and then the physical simulation will just go into any object you can think of. From there, I said, you know what, I'm going to come back to architecture and do some project designs. Then I looked at some designs with Hadith and tried to do the same software that she made, just to create them. Then I created another, let's say, digital simulation where there is the heart and then the blood would go like around it. And then while I had some time at school, I tried to do project design, and I thought of myself, I'm not electric guy, or I can't do that. So I went to IKEA again. I bought a light. Then I created the geometry. I did laser cutting. I put them together, and then I decided to make a mold, the same as we did in the school with the sushi. And then when I poured everything, it collapsed because there wasn't no structure to it. So I had to do another, let's say, another geometry, and I had to embed the light inside it, and the experiment worked. And the idea of this lamp is, so it's played with the equilibrium where there's 2 points, so each one can hold the other side. This is the table I tried to design. I went to a chair and I used the same technique I used for the branching technique, but an Eames chair this time. An Eames chair, because this one was, I wanted to try the Arabic seating, so I had to do something with that. I want to see how it's going to do. So as you see, the scene was made in a few seconds because of the, let's say, automation and exploring the new softwares where you can put parameters and ask it to do a grid, and then you can play with the grid. So if you see the grids here, instead of going grid by grid and just create each one by itself, I started playing with the numbers. And at the same time, I did the same what I did with the building insect, where it comes into the chair, and created the chair. So one of my friends, he asked me to send this to Eames chair company and told them, we have a new set for you. So that was some of the tests and some of the experiments. I came back again to the 360 images and I tried to manipulate the 3D. So I did this, where you can even play with physics and just mess up your mind and start thinking of. At the same, the guide also is. We take 360 of the guy, and then I try to do a lot of techniques on the person, also with the geometry and with different softwares. Those were some of the experiments. So it's always like pushing me, there's something that pushed me away and then try to come back to architecture. And I actually like this, the shape of that when it stops. And I was thinking, why don't I just make sculpture from an animation? So I did another test where I played with this geometry. So after I did this test, let's say a few months later, someone asked me, he told me, you did this, how are you going to build it? You're not going to build something's moving. At the same time, we had to go to a trip to Autodesk in their office in San Francisco. When we went there, I found something very interesting that looks like what I did in the animation, but this is real life. So what they did, they projected light and they did the 3D model. When they turned the 3D model with the light, you can see the model starts moving, the geometry. And playing. You can see it. So you can see it moving and playing. So that also brought up a new idea for us, how we can, as architects, design something that's moving, not only just permanent thing. I tried to use the Islamic geometries and also did the branching technique. The same thing, where I asked it to go out from this. In this simulation, I used wind instead of just following the surface. This thing is using wind. So you can just find the wind in some city and you can transfer those winds into 3D pictures, as you see. So after that, I came back to Saudi Arabia and I started working with FA consultants. So if you don't know about FA consultants, they have been in the market for more than 40 years. And what I found interesting about their office is they allowed me to use different of softwares to produce the work. They did not just ask me for one software. So that's also brought me back to what I was doing in Masters and then applied to that. Of course, along with AutoCAD and the drawings, the construction documents, I'm making them ready to submit for the clients and for the construction documents. The other projects I worked with them was an MRE project. So it was zoning drivers where there was a living, activities, shared gardens, surface access, and land division. I did some algorithms calculations to test the whole possibility of doing the land. The right, left, up, down, all the possibilities just to create the final image, the final design. So the client asked for, let's say, a private villa here, and the rest is resort. And I used Rhino to action, to explain the idea of a single tectonic unit, exaggerate it to create the geometry, and then apply it to the grid, and then create the architecture. So it's not only just, let's say, squares, but you try to play a lot with the geometry, with enhancing let's say, the geometry of the site. So there was the water system in the middle. We call it the spine, where this spine in the middle, people can gather around it, and there's the gazebos and everything where you can sit and enjoy the view. And at the same time, the client asked for umbrellas. So we told them why not just using something from the architecture, from the design itself, instead of just adding an umbrella in the site. So we had to do some design to it. That was the area shot, and that was the front view, and also from his own private villa, and that was the spine in the middle where the water goes into the site. There was a top view of the site, and he asked for like 2 phases. The first phase is just build his villa, and the other phase is just gardens until he gets approval, and then he can do the results. So we did the spine, the people can go around it, and upgrade it. After that, I missed what I was doing in Los Angeles with experiments, so I tried to do more geometries, and if the architects they asked for project design for their office, so I tried to use same geometries, same designs with Hadid, and using different softwares, and did different visual effects just to show the final image. We tried to have some geometries. Then we pushed that for a 3D printing resin just to test let's say the piece and make sure everything is right with it and it's working well. So we did the resin 3D printing. So what's if you guys don't know about the resin 3D printing, is a liquid that the model starts building from laser. So it makes it instead of let's say liquid to rigid bodies while it's building by the laser, as you see here. We'll use the laser to make it rigid. We did the test and it was working. Now I just wanted to talk about what is computational design, since in the lecture we talked about parametric design. So the main software, I think it was Rhino, but before talking about the software, computational design is you use computer in your designs, and the main thing is parametric design. So what is parametric design? Parametric design is, let's say, you give the software numbers and goals, and the software just follows what you have. So you have the geometry, and then you can control the geometry by just changing the numbers. So you can make it very high, very low, very small, very big. It depends on your design. So there's one guy, his name is Jasper Waldron. He's the founder of Finch 3D. He's going to be launching his software. It's a plugin to Rhino and Grasshopper, where he is going to automate the process of designing every piece in the house. So you just have the geometry and then you just scale up and down. So it's not going to just scale up. No, it's going to scale up with the geometry, with changes and all that ready for you. And we can also see some of the works he produced with that software. It's a very powerful software. And I like the image in the left where you can even manipulate the house while you see it in the final run. And also in the right, you can see how it changes the interior of the place. So over the weekend, I tried to, let's say, demonstrate a very quick walkthrough to show what's Rhino and what's crossover. As I talked about it, since we learned from it, and they did a lot of facade system and architectural work from it. So I built the surface, and I can control the points just by driving them up and down. And I did rebuild, where instead of 4 points in the corners, I changed it to be 5 points. And this process can be applied not only 4 or 3, it can be 300, 400, depends on the design you're wishing to create from that software. So I came back to 5 by 5 grid, and then I started manipulating them, driving the points up and down based on the surface I wanted to take. So I drive the 2 points from the middle to create a dome, let's say an entrance. And then I wanted not just to have let's say spherical shape, I wanted to have more geometric shape. So I started playing with the geometry. So from there I went to grasshopper. I'm going to explain how you move from Rhino to grasshopper. So grasshopper is just going to automate the work for you, and it's going to make it faster for you. Instead of going to each panel and change it, grasshopper is just going to do the work for you, where you just plug in the surface. As you see, I already wrote the definition before, and I plugged this surface to it. So now the surface is in grasshopper. Whatever I change the numbers here, you can see them changing here, instead of just going and do rebuild and do it again. From there, I did something that command that's called revert, where you change the geometry and then you can play them from outside to inside or from inside to outside. So that was the main surface, and that was the surface. I applied the command to it, and with just this button you can have the geometry ready for you. So I want to make it, let's say, smaller, bake it, and then you can see it in Rhino, where now the geometries are applied to all the surface. So I changed the geometry to a smaller geometry and then remade it again. Then I tried to have, let's say, voids in the surface. Instead of a very solid surface, you can have a structure. And that even could help to build structure base. You can just talk to the, let's say, the structural engineers, and you know how much to spend for the building, and then once they give you the numbers, you can try to manipulate the surface and the panels and make them ready for fabrication, which is the same process that was used in the previous projects I showed in the Broad Museum. And you can create like different variety of surfaces, manipulations. That's also, I wanted to try something with the softer edges, if I try to create this geometry instead of triangulate it. So as you see, you can produce a lot of geometries within just press of button, and you can even come to one of those surfaces, and you can just press it, and you change it, and the whole parameter changes for you.
And do you know the thickness over here?
The thickness, I did not put it, but also there is another command where you ask it for a thickness, and it calculated that for you and make a thickness depending on the surface you have. So it's not only just offset from any side. No, it's going to create based on algorithms where it's doable and it's going to be ready for fabrication, not only just for visual effects. And that's the difference between some of the visual effects programs I used and Rhino and Grasshopper. Rhino and Grasshopper is a very practical software where you can just move from design to fabrication at the same time.
So let's say by trying these softwares, are you trying to come up with an idea, or are you just doing it for fun?
No, with this one I was just experimenting with the material just to show how capable the software is. But you can apply that to, let's say, a skin system, to a facade system, where, for example, if you have system integration, where the sun hits your building, and you want to avoid that, so you can do the point attractor, where the facade will just turn its back to the sun, and it would create openings for you. And you can start playing with the parameters. So each number you change it is going to give you a new possibility of working with it. So this is only one example I just made over the weekend just to show that I'm applying. And at the end, I would like to share with you my Instagram. And the reason why I wanted to show it, because I wanted to tell the students that I got 4 job interviews because of my Instagram. So I thought this would be a very powerful point for students to show themselves, to show their work. It's just to do what they do, and they just post it, let the people know about it. And that was, I'll tell you one story I had in the US. So I went to apply for a very big firm in Los Angeles, and I got declined. They did not accept my application. Then I just went home. I took the video I still even have the video of the portfolio. I just took video of the portfolio and I said, do you have a job for me? And at the same time, it was very coincidental, the same company that refused my application, there was an architect that follows me on Instagram. So he sent me a private message, and he told me he would like to make an interview with you. And the next day I went to him, and I got the job for them for 6 months, and then I came back to Saudi Arabia. Thank you so much. I hope you enjoyed the lecture, and if you have questions,
First of all, I would like to thank you for this amazing lecture you gave us today. My name is Abbaas. I'm actually a lighting designer. I have been practicing lighting design since 10 years now. One of the things I think that there is a great link between what you're talking about and parametric design is actually a very old historic structures that were found in Islamic buildings. And I was trying to actually do some research about them due to their amazing form of shadow and light. They are the muqarnas structures, muqarnasat. And when I was doing actually a research, I found out that there is a Japanese architect who analyzed, I think, all the muqarnas structures available in Islamic monuments, and draw them in the same. You have one slide that shows the 3-dimensional shapes as a flat 2D design in the beginning of your slide. I don't know if during your studies or during your analysis and designs, have you ever tried to, to link the knowledge you have with research on مقرر structures, because really nobody would have thought of it, but I think studying them, it would really show how Muslim scholars in the past, although they didn't have softwares, the way مقرر structures are done, it's really very amazing and unique, and you would say how would they able to plan such complex forms without software. I mean, it's just يعني هذه بس إضافة حبيت أتكلم عنها، لأنه أتوقع ممكن أول شيء يكون فائدة لك وللجميع ولي أنا شخصيا. أنا طبعا بس I only watched the Muqarnas forms as an impact of shadow and light, but of course they have many different functions. I just wanted to ask if part of your studies, during your studies in the States or later on, have you ever analyzed Islamic forms during your research or not? This is my question. Thank you.
Thank you for your... you actually brought a very good point to me, which that was one of the reasons why I came back from the US, is just to show the knowledge and also to teach the knowledge, the software and the technology with the architecture. And that's actually something I've been thinking a lot, is to not only the Islamic architecture but also the tradition of our country and involve that with the technology. So I did, let's say, the first part where I learned the technology and this part, and now, let's say, my mission is to incorporate the technology with our tradition and design and see how this would come up with new ideas and new fields.
Yeah, it's for everyone. I just want to know about the first project. What is it? Is it a stadium or something? Because I got confused. The first project you did at the university while you were doing your bachelor.
This one?
This one. No, not. Yeah, this one.
Okay.
There's another bit here. It showed like a stadium there. Yeah.
Yes. So this project is an athletic center. So athletic center that's based on the hillside and goes all the way to the water side. And we had to do it accessible, ADA accessible, where people can go even with their, let's say, wheelchairs from the top to the bottom. So the experience is people would come and they would park their cars here, and then the lobby here, as you see it here, the plan of the lobby, and then you could come down and the lighting would be projected between those two surfaces that they build together, and they create zigzagging between the lights so they can come through the building. As you see here.
So what's inside?
So it's an athletic center. It has, I actually did not plot the program here, but what's inside it, there's the lobby, there's the field, there's the gym areas over here, on top of the train tracks, and then there's the pool at the end of the site. So it's a very, let's say, rectangular site that goes from the top to the bottom, and you had to do an experiment where you go through it from the top to the bottom, but at the same time you find, let's say, the basketball field, you go down more, you find the shops, you go down more, you find the gym, you find the pool by the end of the site.
Hi, I wanted to thank you as well for this amazing presentation.
Thank you.
So my name is Rahman Sarmi. I'm an architect and a product designer. Throughout my studies, master's and with BA I did, no one's ever encouraged us to look at like 3D design the way you did. I never heard about fractional 3D. Yeah. And as well as the stuff you did with Cinema 4D, we were never encouraged to use that. Where would you say you got like the inspiration or that motivation to go ahead and learn about all that stuff?
Yeah, so I think I mentioned before, when I got into the master's degree, where the competition was very hard with the students there. So everyone knows a lot about technology and how they can manipulate it into architecture. So I had to go and start learning software just to compete with them. Because the first spin-up I did in the masters was the worst spin-up I did. And the professor actually told me, you might get expelled with whatever you have in this wall. But then the next semester, I had a class with the dean of the same school. And the reaction for him, he was, did you do that or someone did it for you? I think there's a company that did that for you. So I had to like push myself and self-learn, not only to, let's say, just to design something, but also to survive, just to pass that class. And from there, it opens up a new things for me.
Thank you.
Thank you.
I'd like to thank you, like the others, of course, for the great presentation.
Thank you.
I just want to hear from you about your experience when you came here to Saudi Arabia in terms of what you saw in the architecture practice. Now, I understand that probably in the US especially, there has been a lot of like, experimentation with geometry, and sometimes not to produce a certain thing, it's just to see where we can push architecture and design and geometry in general. Now, do you like see something similar here? Is there like some kind of practice that somewhat allows this opportunity to experiment and to see where we can go with geometry? Or do you think like we're being a little bit, I don't know, business as usual, kind of luxury? And what can we do about it as like architects, in your opinion?
So I actually, what I saw since I came back, it's been a year since I came back from the US. Let's say I'm not gonna say the worst part, but the construction side in Saudi Arabia is very limited, and we work with contractors that they don't even have computers, and they don't even have working drawings, where we just do their drawings to show them how they do it, and by the end they do it in the wrong way. And the example for that, you could see the King Abdullah Financial District. When you go there, it's beautiful buildings designed by very famous architects. But when you go there and you go very close to the building, you see something that's like very disappointing. So I think as architects, to push whatever we have, it's not about vision as architects, it's about, let's say, enhancing technology use and enhancing technology use not in the architecture field, but also with the contractors and those buildings that those people who can, let's say produce those buildings for us. So I think it's very crucial for us not only to, let's say, to judge him, but also to teach him. As we saw the example of Frank Gehry, when he collected 10 contractors that they said it cannot be done, and he taught them for a year. Then they came back from him, they told him this can be done. So I think it's, let's say, between the architect and contractor to elevate this issue and to connect them together and to show our design.
Well, what can we say about like the practice itself within like the design process? Would you think that we have enough space for architects to actually experiment in like firms, for example?
Well, based on my experience, I've been a year. It's been a year since I came back from the US, because I was living in the US since it's been more than, I think, 10 years since I was in the US, from 2009. So I'm not quite sure what are the, let's say, all the offices. I've heard about a lot of offices here that they want to integrate technology more, and that's why.
Basically, architecture is like now is some kind of fast food, supposedly. So it's like a factory that's producing piece after piece after piece. So it's something like fast and goes without thought.
Yeah.
This is like my expression about what's going on here. I don't know. Maybe my view's been limited a little bit, but this is what I feel like from looking around at the products we see. It seems like not a lot of thought has been going on into the design of things.
Yeah, hopefully I think in the next few, let's say, few years, there's been a lot of change. Before, no one would know what's interior designer. They don't know, they just know architects. But now you know the interior design, and they can design for you. And so now it's been moving, which is a good thing, where people start to know that there's design, and it's not something that you just put in your house and you can go. There's thought, there's light studies, there are a lot of things to do. So hopefully it can change to a better quality, but at the same time, as architects, we should not just wait for them to, let's say, to agree on that, but also to push more, and also to put our hands with the contractors and try to, let's say, to teach them more ways to do it. And also, the clients also need to, let's say, appreciate and understand design, because
Yeah,
they just
this
think
is the biggest problem. We need
Yeah.
probably an enlightened client to be able to work, and this isn't the case all the time.
Yes, yes. And one story our client told us when he came to our office in FA Architects. He told us, I really believe in design, because I asked you guys, he asked the office a few years before to...
I work in consultancy, so I'm dealing with the design as well. And I completely agree with you that there should be kind of a collaboration between contractors, architects, engineers, and all the other fields to support a good design in the end.
Yeah.
My question to you, have you thought about how technology would help with environmental design from a perspective of the users of the design? So now I see that you're playing a lot with sculptural kind of architecture.
Yes.
Creating monumental buildings,
Yeah.
iconic buildings. Where does the users of the space come into play?
Yes, so as I mentioned, I think what I've shown here is more of a creative way, but I think there is another thing for technology, is the system and making things work right and efficient. So we have to connect between that. I think it's our, let's say, our goal, not only to learn software to do creative stuff, but also to learn technology to help us to, let's say, automate our process, to help us to, let's say, analyze whatever we have, let's say, from system integration, from sustainability, how we can enhance technology in not only design, but also in systems, and also connect all of them together to produce one mass building that has all of them together.
But that's also related to the operation side
Yes.
of the building.
Yes.
I'm talking about the user, the human.
Yeah, so you have a good point, because a lot of people, they said those softwares are gonna be, let's say, taking the human from this. But what I'm seeing is technology is only a tool that could help us to produce whatever we have. But we have the knowledge, we have, let's say, the creativity, we have the function to think about it. So let's not only use the technology to just to produce for us and to do the work for us. As a human, we have to have a vision, we have to have, let's say, an idea that we push for, and then we just use the technology as enhancing part to enhance our work and system.
Assalamualaikum. Thank you so much, معتز, for the presentation. I'm coming from an academic field, and I know from your presentation that you were encouraged to learn more about technology because it was because of your peers. كان يعرفوا أكثر يعني that's why you started to learn more. I would like to ask a question. If you, as a professional, you were teaching in a university, which kind of rules, guidelines, or agenda that you can provide for your students that can encourage them to learn more about technology, so they can develop their design and
I think the first studio for me, I was designing just boxes, and the teacher came to me and he told me, "You're a student. You know, your design is not going to be built tomorrow. So why don't you just go creative with the work process?" So from there, I started just doing more creative things and to push myself, because I think making boxes and very basic designs, I think it's very easy to learn. Like learning AutoCAD, for example, is, let's say, 1,000 times easier than learning another software. So we can learn the basic things, but at the same time, we don't just, let's say, lock ourselves to those things. We need to be very creative, especially in the academic part, because in the academic part we can push it even more than in the real field. and then we can connect it with the real field, with the very contractors and very good architects.
Yes, I'm an analyst in the architecture department, principal university, and I would love if we can invite you actually, because the new vision for our department is to go with more technological tools, and now we have fabrication lab, which we have all the resources, but we need some inspiration and some motivation from professionals like you. And thank you so much.
شكرا.
في حد؟
Thank you, معتز, for this amazing lecture. This is not new to me. I've seen your work. I've worked with you for a long time ago, and I'm very proud. There is one issue since I came to Saudi Arabia. Clients don't, I'm not going to say don't appreciate design or architecture.
Yes.
They miss the value of architecture design, since we spend a lot of time and a lot of effort, and we stay for nights without sleep doing these projects.
Yeah.
And by the end of the day, some clients or people who doesn't know design well, they come and ask for less value of cost, or sometimes they ask for free design.
Yes.
In your vision, what do you think the solution for this issue? Since is it the society who's lacking the love of design and architecture, or is it our role as architects and designers to push the limits and to teach people and make them be more aware about the design process, and all, like this lecture today shows us the hard work and the time you put in your work and the imagination you put, and all of this has a cost.
Yes.
It shouldn't be given free.
Yeah.
What do you think?
I think from my point of view is you need to work within your budget. You can be creative with a very low budget, and you can be creative with a really high budget. But we cannot spend nights, as you say, and we work in a lot of projects, and we know that the client is not going to build because he doesn't have the ability to pay. So you focus on the budget you have, and then you work within the budget you have. Because you can find clients that they don't pay a lot, you can find clients that pay a lot. And I always like to bring the example of Frank Gehry. When he did that, he did not just go to invent software, and he does not know that his building will be built. Because he was working with his budget. And all the 10 engineers, the structural engineers, that they came back to him, all of them, they were below the budget he was given to. So that was encouraging for him, just not to build something crazy, but at the same time within his budget.
Excuse me, regarding this question, is he talking about the residential clients, you mean?
I mean, clients in general, they sometimes don't have the knowledge or the awareness of how costly the design is, and how much time we put in design. I'm sure all designers, they have non-sleep for at least 3 nights, 4 nights.
You dream about this.
Exactly.
Yeah.
So there is a cost for design that society should know about and should value, because you're not just a contractor who had a catalog. No, you stay for nights and days and think and customize design. So this is the value I'm talking about.
The problem is some of the contractors get another design and give it to them for because he already had the price for it.
Yes.
So that's the thing. And I think some contractor even give them that design as in plus to do the job.
Yes.
So I think that's the problem.
Yeah, and I think there is a lot of knowledge with that, and it's changing. It's been changing. People started realizing about and understanding about design. So hopefully we can push, even especially the new generation, we can try to push for that thing.
They don't know it's going to save them a cost. It's going to save them a lot of things.
Yes,
like
because
in the old design, you see a lot of doors, a lot of windows. It's
yes,
not flooded.
yeah, well, they are not functional. So you are trying to not only to design for them, but to help them to save money, even the system integration and all that. Yes.
Also, I think this is a larger policy level conversation also, because we need to find local Saudi talent and patronize those talents here. And for example, if we talk about buildings like Infra or the King Fahd National Library or the metro station at KAFT, I mean, these are done by people like Shahada and Zahra, and while we have a pool of Saudi talent that must be recognized for public projects so that it becomes mainstream and all these iconic landmark projects do not go out. When we have such an amazing talent over here, the projects at the public level should be commissioned to Saudi architects. I mean, like for example, in India, the Taj Mahal wouldn't have come in place if Shah Jahan would not have commissioned it. There has to be a patronage of the art, and this is a larger conversation at policy level, so that these iconic projects come to the Saudis and do not go out of I mean, that really raises the standard, but it also is unfair to the amazing talent that we have.
Yes, and it would be even more powerful when the Saudi talents do that, because they know about the culture and the tradition more than the other countries from outside. So hopefully we can...
Hopefully we can have a landmark which is by Abbas.
One final question is, talking about the human aspect of challenges that you mentioned in your presentation.
Yes.
Chinese, they would see what you're doing, see others, and particularly, and they would try to copy and make it better.
Yes.
So does that, you mentioned that you always step ahead. So does that make you a creator and they are the copier?
Well, I actually mentioned them not because what they do. I think it was a very good source for me to have the Chinese friends. I have a lot of Chinese friends. Yes, it was a very good challenge. Because not only that, because they push even more than what I do, and I can learn from them. So it's let's say we call it a healthy competition, where I learn from them and they learn from me, and we try to push more. So
proud to have you here in Saudi. Looking forward to see one of your kind of very soon.
Inshallah.